Hello everyone, welcome to Excel Maths. We are going to be discussing question number 7 from June 23, Pure Paper 2, Real Paper Series. So as you can see over here, we have an implicit equation. Implicit equation you would be knowing is the one that is where it's difficult to rearrange it for y. So as you can see over here, we can't really. Can we rearrange it for y? We have y and y square. We can't. So we differentiate it implicitly and we call it implicit differentiation. So for implicit differentiation, what the rule is, I'm having it here. If you can see, because you're going to be differentiating it, y to the power n will be n y to the power n minus 1, exactly as we differentiate x. The only thing will be dy by dx. You're going to be writing dy by dx. Say for example, if it is written 2y to the power 5. So implicit differentiation will be 10y to 4 dy by dx. So we have to write dy by dx. Let's do this one. So we have to find out dy by dx. We can't really rearrange y, but once you differentiate it, you're going to be getting dy by dx. That is possible to rearrange and get that. So overall, when we are differentiating, we are trying to find out dy by dx, right? So let's try that. If it's not like this method, then we are going to be following the other method. Maths has many ways. You choose yours, right? Okay, so let's continue. A part, we have x to the power x cubed plus 2xy plus 3y squared plus 47. Okay, so x cubed is going to be 3x squared plus, okay, over here, be careful, let me show you. It's 2xy, we're going to be using the product rule. So first we're going to be differentiating x. So differentiation of x is 1, right? So 2 and differentiation of x is 1, and we will be keeping y, not changing. Then plus, the other time we are going to be differentiating y, so we will keep x the same. So we have written 2x the same. Y would be 1 only, but when you are differentiating y, you're going to be getting dy by dx. Does that make sense? So we'll be taking it there. Okay. So we have it here. Now 3y squared is simple. 3y squared, what it would be? Yes, 6y. And what? Yes, dy by dx. Don't forget, please. And constant is 0. Now what can we do? We can take dy by dx common. We can rearrange and make it the subject. Okay, so we're going to be having 3x squared plus 2y plus, let's take dy by dx common. Dy by dx is 2x plus 6y. That equals 0. Okay, so can we say that dy by dx is going to be a negative 3x squared plus 2y over 2x plus 6y, correct? And this is what we've got for 4 marks. So let's quickly match this first, and then we'll be switching to the B part. If we made any mistake, we'll be correcting that. So question number 7, a negative 2y plus 3x squared. Yeah, same, the order is different. And 2x plus 6y. Okay, so we've got 4 marks here. Perfect. Now for B part, the point P, which is minus 2, 5, lies on the curve. So it is lying on the curve. Find the equation of the normal to the curve at P, giving your answer in the form this. Okay, so we have to find out the equation of the normal to the curve. So let me write here. For normal has the gradient. Normal is perpendicular to the tangent, isn't it? Correct? So whatever the curve, like the dy by dx, for writing normal, we need two things. We first need the coordinates, which we have minus 2, 5, and the other thing is the gradient, right? So I think this dy by dx is going to be helping us finding out the gradient. Over here, I'll also tell you not to do, like what not to do. Generally, last year, many students lost their marks for that silly mistake I would just make you aware of. Okay, so for B part, we have P, which is a negative 2, 5. Okay, find the equation of the normal to the curve P. Equation of the normal. So normal will be having the gradient, which is a negative reciprocal of that one, tangent. So let's find out dy by dx first. Dy by dx at, I'm doing here, dy by dx at negative 2, 5. So it's simply substitute negative 2 and 5 there. So 3 negative 2 squared would be 4 only, plus 2 times 5 over, down there 2 negative 2 plus 6 and 5. Okay, perfect. So it's negative 12 and 10. So that gives us a negative 22 over 30, take away 4, 26. That comes a negative 11 over 13. So we have now, what you're going to be doing, you're going to be writing, taking this gradient and these points, and y minus 5 equals minus 11 13ths, x minus 2. That would be 13y minus 65 is equal to minus 11x and minus 22. Definitely not. This is what the mistake you are doing. You've got dy by dx, but it is not the gradient of normal. It's the gradient of the gradient of the curve. The gradient of the normal is going to be the negative reciprocal, right? So please avoid this. Don't do this. And this is what many students did, because when you are doing processing, getting something, you actually miss some steps. So be careful. Just not to miss those steps, I would suggest you to write like the gradient is going to be a negative of whatever you get. I mean, I personally share my students to follow this thing. So this is what the dy by dx you have, and the gradient of the normal is going to be a negative reciprocal of what you get. So overall, our gradient is going to be changing. So what the gradient will be? It would be 13 11ths for the normal. This is the gradient of the normal. Okay, so let's substitute 13 11ths and x plus 2. Now it gives us 13. Oh, sorry, let me fix it. Okay, so it will, let's multiply 11 whole equation by 11. So it would be 11y minus 55, that is equal to 13x plus 26. So because we have to write it in ax plus b by a particular form, so can we write the 13x minus 11y? It goes there, 55 plus 26 is 81 equals 0. So this is the final answer. Hope it makes sense. Let's match it. 13x minus 11y plus 81 equals 0. And yes, this is what we've got. Perfect. Okay. So yeah, we've got marks over here also. Okay. Bye-bye. Take care.